Okay, we're going to start working on the study guide, and I'm going to do page 1 in this video. Okay, when I'm working with I kind of start by treating it almost like you would treat a variable, like you would treat an x. So I'll distribute minus 15i, and then combine the like terms. So 6i minus 15i, and the 6 doesn't have a like term. Usually you write the whole number first, and then the imaginary part of the number. So 6i minus 15i is negative 9i. Done. Okay. Now, the tricky part on these, if something is squared, that means there are two of them being multiplied together. So the first thing I want to do so I can figure out what I'm supposed to do is I'm going to write it twice. Once I see it like this, I'm like, oh, I'm supposed to FOIL that. So I'll do 49 minus 21i minus 21i. Negative 3i times negative 3i is positive 9i squared. These are like terms here, so I'll put those together. 49 minus 42i. And over here, this is the part that's maybe surprising that you can simplify it a little bit more, and that is that I squared is negative 1. So I have 9 times negative 1. This means I'm going to be subtracting 9. These are my like terms now, 49 and negative 9. So I'll get 40 minus 42i. Okay. Next, this is similar to the first problem. I'm just going to combine like terms. I just have to make sure that I distribute this negative to both. So this becomes plus 4. And then I'll put my like terms together. Negative 6 and 4 is negative 2. I minus 7i is negative 6i. Done. Okay, the last three are questions about the pattern. And let me find some scratch paper. And the pattern for powers of I is this. So we have, I like to kind of draw it out. It's a repeating pattern of 4. So the way that we remember it is stupid. It's I won. Okay, what did you win? A negative sandwich. So you make the ones in the middle negative. That's just the way that you remember the pattern. This is I to the first power, I squared, I cubed, and I to the fourth power. But it's also, this is I to the fifth, and this one's I to the sixth, and this was I to the seventh, and I to the eighth, and I to the ninth, 10th, 11, 12, I to the 13th power. So if you want to know what I to the 13th power is, it's just I. It simplifies to I. So given any number, we can kind of figure out where it goes on this pattern. I don't want to count all the way up to 51, but I know that I to the 48th, because it's a multiple of 4, see how everything in this column is a multiple of 4, I to the 48th will go here, so I to the 50, I to the 49 would be here, I to the 50 would be here, I to the 51 would be here, so that's negative I. So I to the 51 is negative I. And I to the 14th, I've almost counted up to 14. I can go ahead and do that one. That's negative 1. And I to the 20th, this would be 15, 16, 17, 18, 19, 20. 20 is a multiple of 4, so I know it's going to be in this column. So that's equal to 1. Okay, that's my pattern for powers of I. All right, and given this function, there's two functions here, f of x and g of x. Find g of f of x. Now, the fact that the g comes first lets me know that I'm going to be starting out with the g equation. Here, I'm going to take out that x, though, and leave a space. So I've removed the x and I've left a little space. What I'm going to fill it with is f of x. So I'm going to put x minus 4 here. Now, this is a lot like this problem where you have to remember x minus 4 squared means write it twice and then FOIL it. X squared minus 4x plus 16 plus 5. Combine like terms. That's g of f of x. Okay, part B I'm going to do in 2 steps. I find it's hard to do it all in one step, so I sort of see these as parentheses, and I'm going to do what's inside the parentheses first. So the first thing I'm going to do is g of negative 3. So that means I grab the g equation, this one, and I plug in negative 3. Oops, plus 5. So this is 9 plus 5. Negative 3 squared is 9 plus 5, so g of negative 3 is 14. Okay. Next, I'm going to, since I'm working with my original question is f of g of negative 3, That is the same thing as saying f of 14, because now I know what g of negative 3 is. So I'm going to replace it with a 14. Go up, get the f equation, 14 minus 4, so it's 10. Okay, factor completely for number 3. When it says factor completely, that means you are absolutely looking for a GCF first, and you're going to keep on factoring until you can't factor anymore. So I'm looking here, 6, 26, and 24, they all have a 2 in common. X to the 4th, x cubed, and x squared, they all have x squared in common. So I'm going to divide each one of these terms by 2x squared. The 2x squared doesn't go away, though. It goes out there in the front. 2x squared, that's what I'm taking out. Then I'm going to divide, so I get 3x squared. This becomes minus 13x and plus 12. Yep, plus 12, because x squareds will cancel. Okay. From there, I can probably factor this again. I'm going to do the magic x method here. So I'm working just with what's in the parentheses here. 3 times 12 is 36. Factors of 36 that add up to negative 13. Well, they both have to be negative. 9 and 4. 9 and 4. Negative 9 and negative 4. Divide them by the leading coefficient, which is 3, and then simplify. This is in simplest form already. This one I can simplify a little bit more to be negative 3 over 1. Here's my factors. X minus 3 and 3x minus 4. I'm taking a moment just to check and make sure it's right. Okay, that looks good. Okay, over here again, hey, there's a GCF. It's 5. The 5 doesn't go away, though. It goes here, outside. What's left inside is 4x squared minus 9. Now, if you're paying close attention, you know when there's two terms, it's often a difference of squares. So it's like, how do I make 4x squared? 2x times 2x. How do I make negative 9? Positive 3 times negative 3. Difference of squares. Okay, solve the quadratic function by factoring. For this, I need to first set it equal to 0, so I'm going to have to subtract 2 from both sides, and I'm going to line that 2 up with the 16 because that's its like term, and I'm going to add 6x to both sides, so I'm going to line it up here. This side will become 0, and this side is 2x squared plus 11x plus 14. Here we go again, another magic x problem. 2 times 14, that's 28 on top and 11 on the bottom. Factors of 28 that add to 11 must be 7 and 4. Divide by 2. This becomes 2 over 1. Here come the factors. 2x plus 7, x plus 2. Now, unlike the previous problem where we were just being asked to factor, here we're asked to solve. This says solve it. So now I need to go and make two mini equations like this. Subtract 7 from both sides. 2x equals negative 7. Divide by 2. Negative 7 halves. Subtract 2. X equals negative 2. And this is already set up for you, your solution set. You're going to put negative 7 halves and negative 2. Let's cancel. Okay. Next, we had some like this for our warm-up. Solve by taking square roots. So when you're taking square roots, you have to get x squared by itself. That is your, a problem like this. We're trying to get the x squared by itself first, that part. Okay. So the first thing I got to do is subtract 30. So I get 4x squared equals negative 24, and then divide by 4. X squared equals negative 6. Okay. Once I have x squared by itself here, now I can take square roots. Take the square root of both sides. Once you take the square root of both sides, this becomes an x. And this side, you got to remember you're going to get two answers. Okay? So it's like, well, what are we going to do to simplify the square root of negative 6? I'm going to go over here to show you. Negative 6 is 2 times 3 times negative 1. There's no pairs, right? There's no pairs of numbers. So there's not like we can bring a number out to the front. But I have a square root of negative 1, so I do need to bring an I to the front. So this simplifies to I times the square root of 6. So my solution is plus or minus, because I have 2, I square root 6. So my answers are I squared root 6 and negative I squared root 6. Didn't have room. Okay. Part B is a little bit odd because it's not in standard form. We're used to it being in standard form, so it looks more like that. But we can still solve this one by taking square roots, using the square root method. So first I'm going to add 8 to both sides. And I'll do x plus 3 squared equals 25. And then I'm going to take the square root of both sides. This one becomes x plus 3. That's nice and easy. Square root of 25, it's really easy to miss this, but it has two answers. It's plus or minus 5, right? When you're using the square root method, be assured that you're going to get two answers, plus or minus 5. And then all that's left is to move the x over to the other side by subtracting it. So I get x equals negative 3 plus or minus 5. Okay, so this is a little bit weird. The first answer is negative 3 plus 5, and the second answer is negative 3 minus 5. Well, we know what negative 3 plus 5 is, so let's just write what it is. It's 2. Negative 3 minus 5 is negative 8. All right, next up, I'm doing an absolute value equation. I'm going to start by isolating the absolute value, similar idea to square root method. I'm getting this part by itself first. That's my first task. So I have to get rid of the 7. Nope. 23 minus 7, 16. Whoop, forgot my bar. And then I'm going to divide both sides by 2. So this is 3x plus 2, absolute value equals 8. Okay, now it's time for two equations. That's the secret to absolute values. You isolate the absolute value and then you write two equations. First one's easy, just like what you have. Second one, you make one change, make it a negative 8. Now solve. Subtract 2, 3x equals 6, so x equals 2. Subtract 2, 3x equals negative 10. Divide by 3. X equals negative 10 thirds. So I have 2 and negative 10 thirds. Okay, I'm going to pause and continue the video, or continue the study guide in the next video.